So any problem, but let's take it step by step. So we have examples from everything. So we are now in 11 through 16. 11 through 16 on page 514. Use the formulas for lowering powers to rewrite the expression in terms of the first power of cosine. 11 through 16. These are, most of them, very hairy, very long. Let's do one. So pick anything you want. 14. Cosine to the fourth. Hold on to your seats. Okay. I don't know. I haven't never looked at this one, so I don't know how long it will take us, but I think it's useful to choose one at least. Okay. Let me refresh your memory on those two formulas. I will kindly ask you to remember them, however. Sine squared alpha. Oh, well, let me write x. Sine squared x is 1 minus cosine twice x over 2. And cosine squared x is 1 plus cosine twice x over 2. These are the lowering powers. Sine squared 1 minus cosine twice x over 2. And cosine squared 1 plus cosine twice x over 2. And they come from the only formula, I shouldn't say the only, but the formula for cosine twice x. Correct? That's how we determine them. Okay. So now I go back to the problem and I replace cosine to the fourth by cosine squared everything squared and times sine squared. Is this clear? Is this first step clear? I don't have a formula for cosine to the fourth. I only have a formula for cosine squared. But I know I can obtain cosine to the fourth by squaring cosine squared. Are you with me?
Yes.
Okay. Now here is the big difficulty. I shouldn't say big difficulty, where it starts getting hairy. So I replace this inside parentheses by this. So 1 plus cosine twice x divided by 2, everything squared. Now I replace sine squared x by its formula. So 1 minus cosine twice x divided by 2. I haven't done anything yet. I have only replaced the formulas, right? But now I have to square top and bottom, because I can't distribute. I can't do anything else. By the order of operations, I have to square first. I can continue. So, look at the time, and let's see, because I'm curious to see how long it will take. Okay, so I square the top. The top is a binomial. When I square a binomial, how many terms do I get? And before you, excellent. That's what we have an agreement. Remember, those are the baby steps in algebra. Those three formulas. Core, like 1 sine squared plus cosine squared equals 1 here. Okay? So the first term squared is 1 plus 2 times the first times the second. 2 cosine twice x plus the second term squared, which is cosine squared twice x. I already got in trouble. Why? Because I have a cosine squared, and I have to go back and use that formula again, but for cosine squared twice x. So, before I do that, I will separate the fraction. So stay with me, please. So I have the 4 and the 2, which I'm going to put into 1 over 8 in front. And now, in brackets, I have 1 plus 2 cosine twice x plus, and now I have to replace this by something. and then copy 1 minus cosine twice x. Let's take a moment and see what's happening here. I have this fraction that I had multiplied 4 by 2 and put it in front. So then I have the 1, I have this. This has to go away.
Yeah, cosine squared, cosine 2x squared. It's cosine squared 2x?
Yes. So it's cosine twice x, and the result is squared.
Not the inside.
Right, not the angle. It's the answer to cosine that is squared. So you can write cosine twice x, everything in parentheses in the power 2. Instead, to condense it, we write cosine squared applied to twice x, which means cosine twice x, and if it's 1/2, then I square that and I get 1/4. Better? Okay, so for first term squared plus 2 times the first times the second, plus the second term squared. I'm squaring cosine, not the angle inside cosine.
Okay.
Better?
Yeah.
Okay. So then these two are up here. And then I have the 1, I have this. And this, I have to go back to the formula for reducing powers. And now I have cosine squared, but we know what this tells us. We know the pattern. Cosine squared of twice x will be
1 plus cosine 4x.
exactly over 2. So that will be 1 plus cosine 4x over 2. We use the pattern in yes.
And you already took the denominator
Yes.
out. Right?
Why? Because then I will have fractions over fractions and I'll right. So I took this outside. It can wait. I will have to distribute it at the very end, but I don't want it in the problem right now. Okay, so now I will separate this as well, or that's one option. 1 over 2 plus this over 2. This is what I would do. But also remember, after I'm done simplifying a little bit in here, hopefully I can, then I will have to distribute 1 to these terms and then cosine twice x to these terms, and I will get another cosine squared because there is a cosine squared.
Inside.
That's what I said.
Oh my God.
I know. Okay, ready? So we want to eliminate the fraction. I would prefer that. So if I eliminate the fraction is, first of all, I will say all this in here has denominator 1, denominator 2. So this will become 2 plus 4 cosine twice x plus 1 plus cosine 4x. So I found the least common denominator in parentheses here. And I said, if 2 is the least common denominator, this has to be multiplied by 2, and this has to be multiplied by 2. Now I combine like terms. And I can drop, for a moment, I can drop the brackets. And when I multiply, I can bring the 2 in front, because everything will have denominator 2. So this is now 1 over 16. And I will have to multiply 3 plus 4 cosine twice x plus cosine 4x. You understand that these are not like terms. I wish they were.
Okay.
But cosine twice x is not like term with cosine 4x. And multiply by 1 minus cosine twice x. Is this okay? Are we okay so far? I know I write big, but this is going to be 2 pages for me. For you, it will be less. Okay, so 1 over 16. 1, multiply by these 3 terms. 3 plus 4 cosine twice x plus cosine 4x And now I distribute this to these three. Minus 3 cosine twice x minus 4 cosine squared twice x and minus cosine 4x cosine twice x. One of the things I would like you to learn from what we're doing now is for calculus, moving forward. Always try to take the constants out of the equation, out of the problem, if you can. Let them wait for you. Because with that constant or that fraction, the 1/16, it would have been way more difficult to clear this up. Okay? So one more time, here's what we did. Is the step from orange to purple clear? From orange to purple. So I have a 2 plus 1 and a 4 and the cosine 4x. Yes?
Mm-hmm.
So then because I had a denominator of 2 and that has denominator 1, 2 times 1 times 8 would be 1/16. Leave the constant alone outside. This would have complicated a lot. Okay, so now I distributed 1 here, here, and here. And then I distributed negative cosine twice x here, here, and here. Okay? So, this is 3. These two are fine. So 4 cosine twice x minus 3 cosine twice x, it's okay. Power 1, this is okay. Cosine 4x cannot be combined, but power 1, no problem. Cosine 4x, cosine 2x, no problem. Power 1, very easy to handle. I don't have to do anything else. But this is a problem now. I have to change that.
I have a question.
Yes.
Is it, minus, is that?
I write this minus. If I don't write this minus, I know in some books or in high school we were taught not to write anything here. But I was taught to write something. It's not minus minus, but if I don't write something, you may think, no, it's done. But if I write something, it means that something continues.
Okay.
And it continues here, but it's not a minus and a minus. I would have had to use parentheses.
Right, it's the same minus.
Yes, it's the same minus.
Oh, okay.
But if I don't put anything here, you may be tempted to, because these problems are so long,
Yeah.
you may be tempted, oh, it's done. Nothing else follows. You may not look below.
I just thought I had missed something.
No, you didn't. No, you didn't. But again, you adopt this the way you understand it better. But again, if I don't put something here, then you will say, oh, it's done. You may not look. I'm not saying you wouldn't, but I'm just saying it's possible. Okay, so 1/16. 3 is okay. This is positive cosine twice x. This is fine. I'm going to copy this. But then I have a problem with this. This has to be replaced. What do I replace it by? It's the cosine, so it's going to be 1 plus over 2. So 1 plus a cosine and over 2. But now I have to identify the argument based on the pattern. Let's go back to the formula and look at it. So if I have here cosine squared twice x, then I have 1 plus cosine. We used it a few minutes ago. Yes, 4x over 2, right? This is the last cosine that needed to be reduced, its power to be reduced. But now I have to simplify this a little bit.
Oh,
Yes.
wait, I think I missed something. We didn't combine any like terms, right?
We did. So 4 cosine twice x minus 3 cosine twice x is cosine twice x. That was the only one that I could combine.
Okay.
The cosine 4x is alone. Negative cosine 4x, cosine 2x is alone.
Okay, yeah, I see why we're.
So now what I'm going to do, of course, I'm going to simplify 4 and 2 and distribute negative 2 to these two terms. So I have 1 and 2. I will rewrite everything. Keep the 1 over 16 outside. It can wait a while longer. So I have 3 plus cosine twice x plus cosine 4x minus cosine 4x cosine twice x minus 2 times 1 minus 2 and minus 2 cosine 4x. And now it's done. Have to rearrange it, combine like terms, and it will be done. So 1 over 16. So this is 1. This is alone. This is now with these two are together. So this is minus cosine 4x, and then minus cosine 4x, cosine 2x.
In the second term, the cosine 2x have a 4 in front of it?
It used to, but then we combined it with this. 4 cosine 2x minus 3 cosine 2x.
Oh.
So that's why we got 1.
I got you.
And but if you see something that you think it's wrong, it's okay. Even if you are not wrong
No, I just
or are wrong, it doesn't matter. Is that okay?
Yes.
Okay. So we copied. Okay.
One question.
Yes.
Yeah, minus 2.
3 minus 2. Yes. Yes. Negative 2 times 1, and negative 2 times positive cosine 4x. I have to distribute negative 2 to these two terms.
Oh,
It's
okay.
negative 2 multiplied.
Right, but you have
I simplify 2 with 4. 2 divided by 2 is 1. 4 divided by 2 is 2. So I have to distribute negative 2 to these two terms.
yeah, it's negative now cosine.
Right. Is that okay?
Yep.
So I'm checking now. So I have 1 here. I have cosine. I have these two now are can be combined like terms. So that's why I have negative cosine 4x. And this is the last one. And finally, I can distribute 1 over 16. Patiently waited outside. 1 over 16 plus 1 over 16 cosine twice x minus 1 over 16 cosine 4x minus 1 over 16 cosine 4x cosine twice x. So one more time, the person, I will put a problem like this, but no, in 2 lines will be done, okay? Not with high powers, yes.
This one is, this last part of bracket is cosine 2x?
Yes, it was this term. Yes. So the purpose, one more time, of the exercise was to remove any cosine to a power and keep all possible cosines. We don't care about the argument. It can be 2x, it can be x, it can be 4x, 6x, whatever you want, but the power of cosine is 1. So we reduced or lowered the powers on the expression, and we obtained a long expression, but it only had some cosine applied to any argument you want, but the power of that cosine, or all cosines, have power 1. Otherwise, we would have continued to apply the lowering powers formulas. Okay, use an appropriate half-angle formula to find the exact value of the expression. So please choose 17 through 28. We are using a half-angle formula to find the exact value.
Six.
26. Tangent 5 pi divided by 12. So we're specifically told use a half angle identity. So obviously I'm going to think in terms of tangent of something over 2. Excuse me. So, what over 2 will be 5 pi over 12?
Say 5 over 2. 5 pi over 6.
Very good. 5 pi over 6. Everything divided by 2. Remember, when we divide by 2, when we divide a fraction by 2, we really multiply it by 1/2. So only 5 over 6 multiplied by 1 over 2 will be 5 over 12. And then if you remember, I gave you those two formulas that I said I'm not going to ask you to remember them. Since we have a tangent, please choose this or this, and let's find the exact answer. Which one you prefer, it doesn't matter. First one. So 1 minus cosine 5 pi over 6 over sine 5 pi over 6.
So you're saying 5 pi over 6 is equal to.
So one more time. Tangent of 5 pi over 6 over 2 is 1 minus cosine 5 pi over 6 over sine 5 pi over 6.
Oh, okay, I see what you're saying.
Right? Once we identified alpha, now in the formula I only have alpha. And alpha was identified to be 5 pi over 6. Better?
Yeah.
Okay. So what will I have to do now? What will I have to determine in order to get this done? What I don't have, which is cosine 5 pi over 6 and sine 5 pi over 6. But I have to go back to the unit circle. I have to identify the quadrant where 5 pi over 6 lands, or the terminal side is. Where is the terminal side of 5 pi over 6? Knowing that pi over 6 is the small angle.
Quadrant 2.
Quadrant 2. So it's 150, right? 5 times 30 is 150.
Yeah.
So 30 degrees shy of 180. So this is our 5 pi over 6. Once I identify that, what will be my next step? And this is a review for the test.
Cosine positive sine.
Say it again.
Negative cosine positive sine.
Yes, you're right. The cosine is negative and the sine is positive. But what do I need now? Right. What is the reference angle? Good. So indeed, so sine 5 pi over 6 equals positive, and you'll tell me what. And I'm sorry, and cosine 5 pi over 6 equals, as you said, minus, and you'll tell me what. So what do I write? Sine, very good. And here I write, very good. Awesome. So pi over 6 is the first angle, the tiny way angle, the top angle. So what will be sine?
1/2.
And what will be cosine? I have to plug them in to find this. So let's continue. 1 plus the square root of 3 over 2 over 1/2. So I copied the 1. Cosine 5 pi over 6 was negative the square root of 3 over 2, so I had to change this into positive. The denominator we established, it was 1/2. I don't know why I wrote it so far to the left. I'm sorry about that. I have to find the least common denominator in the numerator, which is 2. And what will be the numerator of this? 2 plus the square root of 3. And now I have two fractions that I divide. Say it again.
So I thought we were. I thought it was. I thought we were substitute.
So I have 1, and I have minus, and cosine 5 pi over 6 is negative the square root of 3 over 2, so it's plus.
Yep.
So 1 plus the square root of 3 over 2. And then I replace sine 5 pi over 6 by 1/2. Are we okay at this stage? So now the numerator is 2 plus the square root of 3 over 2. We agree? And the denominator is 1/2. How do I divide two fractions? Good. So what is the simplified form? That's it. And this is the exact value of tangent for the angle 5 pi over 12 using a half angle. Is this okay? Okay. Simplify the expression by using a double angle formula or a half angle formula. We chose double angle formula. Allow me to choose, or you can choose, a half angle formula from here. We already worked on these problems. Let's say 34b. The square root of 1 minus cosine 8 theta over 2. They want us to come up with something on the right-hand side. So what does this look like? Disregard the square root for a moment. If it's 1 minus cosine over 2, it must be sine or cosine. Exactly, because it has minus, right? Awesome. So I already established that it must be sine. But now the question is of what angle? And it's not going to be squared because of the square root. If I didn't have the square root, I would have said sine squared of something.
Right.
But I have the square root, so it's just sine. But looking at the pattern.
Sine 4 theta.
Exactly. This is what it is. Sine 4 theta. Why? Why was it easy to identify? Because now we know how to read those formulas. And we know that they are dynamic. They're not just carved in stone. Okay. Let's choose 37 through 42. Find the sine x over 2, cosine x over 2, and tangent x over 2. Please choose. Which one?
42.
42. In 42, we have cotangent. X equals 5. We are told that x, I can never put the equal symbol for a quadrant. I just rushed. We are told that x is between 180 and 270. What quadrant is that?
3.
Very good. Or quadrant 3. Perfect. And that's all the information. And they're asking us to find sine x over 2, cosine x over 2, and tangent x over 2. Of course, I don't care for tangent x over 2. Once I have sine x over 2 and cosine, I'm done. Good. So sine x over 2, cosine x over 2, and tangent x over 2. This is what we are asked to find. And I will add here the quadrant. I like also to identify the quadrant for x over 2. For x over 2, it's not difficult to find the quadrant. So let's do that just for the beginning. Well, I will obviously divide both sides by 2 because I want x over 2 in the middle. So what is the left-hand side then? What is the right-hand side then? So I know the quadrant for x over 2. The quadrant is 2, which will tell me for sure that sine x over 2 must be what type of number?
Positive.
Cosine x over 2 will be what type of number?
Negative.
And obviously tangent will be,
Negative.
that's it. Good. So now I'm thinking of, because I know that sine x over 2 is positive, what is the formula? And I know that cosine x over 2, oops, I didn't mean that, of course. We already established it's negative. Good, so the formula for sine x over 2. The square root, right? The square root of 1 minus cosine x over 2, and this one is the square root of? Very good. So the whole problem reduces to finding what?
Quadrant.
We did. It's 2. So look at those two formulas on the right-hand side. So the whole problem reduces to finding what? Exactly. Once I found cosine, I plug them in and I'm done. And the same thing with tangent, because I will have that ratio. Good. So let's find cosine. So this is what I'm given. I'm given cotangent x equals 5, and I am told that x is in the third quadrant. What do I expect cosine to be? A positive number or a negative number?
Cosine. Negative.
Negative. It must be a negative number because the angle is in the third quadrant. Okay. I'm given cotangent. How will I determine cosine? So one more time, I'm given cotangent x equals 5. I could use the identities, or I could use a triangle in the third quadrant with cotangent 5. So an angle in the third quadrant with cotangent 5. So this is the triangle. So this is the x. What does cotangent mean? Adjacent. Yes, but I need it in the triangle. So the adjacent over the opposite. Yes, this will be negative. Yes, this will be negative. Because cotangent is positive. And because in this quadrant, cosine is negative and sine is negative. I need to determine the hypotenuse. Since I'm determining the hypotenuse, I will have the square root of the squares of the two legs. Exactly. So can anyone give us then cosine x? Which we expected it to be negative. Exactly. Yes, terrible numbers. But I didn't pick it. You know who did. So, good. So then sine x over 2 will be the square root of 1 plus 5 over the square root of 26 over 2. I know. Which will be the square root of the square root of 26 plus 5 divided by 2, the square root of 26. And the other one is cosine x over 2, which is minus the square root of 1 minus 5 over the square root of 26 over 2. Which will be negative the square root of 26 minus 5 over 2, the square root of 26. Yes, I could have simplified it a little bit. And then tangent x over 2, if you just write negative, the top over the top, right? Because the two denominators will go away. So I'm fine with this. The square root of 26 plus 5 over the square root of 26 minus 5. Yep. Okay, now we know again the same type of problem between 43 and 46. 43 and 46. Please choose one. Do I get to choose then?
Sure.
Okay, I will choose 48. Oh, I meant 43 through 50. Sorry. 48. Cosine applied to twice tangent inverse of 12 over 5. You prefer one with a variable or one with number? I can change it to the variable. Or is this okay?
That's fine.
Okay. So let's identify, again, this is review for the test. Let's identify what we're asked to find. What am I asked to find here? I'm asked to find cosine applied to twice an angle. Very good. That's my angle. Because it's tangent inverse. Tangent inverse is applied to a number and will give us an angle. So then I know alpha equals tangent inverse of 12 over 5. I'll come back to this in a moment. So as you said, we're asked to find cosine twice alpha. But I have to think of the formula. And now it depends on what you want. If you want to work harder, you will use cosine squared minus sine squared. If you want to use less, you work less, then you will write 1 minus 2 sine squared or 2 cosine squared minus 1 and just replace one trig function. So you prefer to determine both sine and cosine, or you just determine one? Which formula would you like to apply? Which of the three?
Cosine squared over 5.
I would definitely recommend that one. Good. So now I'm back here. What do I do next for this problem? But first I have to apply tangent to both sides.
Right.
Because I would not know what to do,
Right.
right? So I have to write the tangent alpha equals 12 over 5, and yes, then I look at the triangle. There is a right triangle with an acute angle alpha, whose tangent is 12 over 5. What does that mean? What is 12? Yes. And what is 5? Yes. And how do I determine the longest side of a right triangle? 144 plus 25. 144 plus 25. 169. Let's go to 169. Good. So now I only want cosine. Twice multiplied by, what is cosine?
5.
Exactly, and I have to square it. Minus 1. So then I have 2 multiplied by 25 over 169 minus 1. I do multiply first, 50 over 169 minus 1. And the numerator will be 50, and then minus I have to change 1 into 169 over 169. So I can subtract. And the numerator is negative 19 over 169. Right? And that is it. Any questions?